Hello and welcome to Scholar's Fair tutorial. Today we'll be looking at mathematics and the topic is indices. So, indices is the plural form of index. So this is the plural form of this. Indices is the plural form of index. And an index tells us how many times a number is multiplied by itself. An index tells us how many times a number is multiplied by itself. For example, we have 2 to the power of 3. 2 to the power of 3. So this tells us that 2 is multiplying itself 3 times. 2 times 2, 2 times 2 times 2. So this is the index form. 2 to the power of 3 is telling us that 2 is multiplying itself 3 times, which is 2 times 2 times 2. So this is just the beginning stage of indices. And in indices, this is referred to the base. So this 2 there is called the base. This 2 is called the base, and this 3 here is called the power. So the 3 is called, or it's called the index. You can call it the index or power. So 2 is the base and 3 is the power or index. Now let's look at the laws of indices. So moving over to the laws of indices, first law is the multiplication law. We have the multiplication law of indices. Now let's look at something like this. So assuming we have something like this, a to the power of n multiplying a to the power of n, how do we solve such? In indices, the fact that the bases are the same, you can see a is here, a is here. So the base here is a, the base here is a. The fact that the bases are the same, you add the powers. So this will give us a to the power of m plus n plus n. A to the power of m plus n. Why do we do this? Because the bases are the same. This is only applied to multiplication law. I think multiplications are here. Now looking at the division law of indices. Looking at the division of indices, a to the power of n divided by a to the power of n. Now the division law tells us that if the bases are the same, we subtract the powers. So we'll be having, this will give us a. First of all, you pick one of the base because the base are the same. Pick one of the base, which is a, and then you subtract the powers. N minus n. So you can say for the multiplication law, if the bases are the same, you pick one of the base, a, and then you add the powers. For the division law, you pick one of the base and then you subtract the powers. Subtraction for division law, addition for multiplication law. It's that simple. Now let's take some examples under this two before we proceed. So let's take examples. Example 1 says 2 to the power of 3 times 2 to the power of 2. And example 2 says 5 to the power of 6 divided by 5 to the power of 2. How do we solve this? Implementing the laws of indices, multiplication law and division law, we have that 2 to the power of 3 multiplies 2 to the power of 2. Meaning that they have the same weights. You can see here we have 2 and here we have 2. So we pick one of the base. We pick one of the base and then we add the powers. So we have here 2 to the power of 3 plus 2. And if you add the power 2 plus 2 is 5. So here we have 2 to the power of 5. And this is our answer. So moving back to the second one, we have 5 to the power of 6 divided by 5 to the power of 2. So applying the same law, we pick one of the base and we subtract the powers. So 6 minus 2, we have 4, and this gives us 5 to the power of 4. So this is for the multiplication law and division law of indices. Now moving over to the third law. So the third law, we have power law, or you can say power law. Now looking at something like this, you have such problem, a to the power of m, or in bracket, the power of n. When you have such problem, first of all, you take out the base. So you take out the base and then you multiply the powers. This is n and this is n. So you multiply the two powers. So we have n. This n is same thing as m times n. So the power law states that you pick out the base first and then multiply the power inside the bracket and outside the bracket. Looking at an example under this, we have 3. We have 3 to the power of 2, all raised to the power of 3. 3 to the power of 2, all raised to the power of 3. So how do you solve this? Like I said, you pick out the base, 3, and then you multiply the two powers. So 2 times 3. And this will give us 2 times 3 which is 6. So we have 3 raised to the power of 6. Moving over to the fourth law. So the next we have is power of a product. Power of a product. When you have such problem, a, b, the power of n. This a, b is same thing as a times b, or the power of n. What you just have to do is we separate these two terms. So we have a, and then we give them individual powers. So a to the power of n multiply b to the power of n. So you just like say you share this man into 2. So this man takes his own share, and then this man takes his own share. So a to the power of n multiply b to the power of n. Looking at an example, we have 2 times 5. Now you have 2 times 5 all raised to the power of 3. What you just have to do is 2 raised to the power of 3 multiply 5 raised to the power of 3. So this is your final answer. Looking at the fifth law. Now the fifth law, it says law of a fraction. Looking at this, for example, we have a divided by b, all raised to the power of n. Same thing we did here. Here we gave each of them their own powers. So for this to give each of these terms their own powers. So we are having a raised to the power of n divided by b raised to the power of n. So if you are to take an example, let's take an example. We have 3 over 4 all raised to the power of 2. 3 over 4 is the power of 2. Applying the same principle to this side, we say give them individual powers. So we have 3 to the power of 2 divided by 4 is the power of 2. And then we solve this. 3 to the power of 2 is 9. And then we have 4 to the power of 2. This is 16. So we have this as 9 over 16. 9 over 16. This is our answer. We look at the next law. We call it the zero index law. So for the zero index law, it states that anything raised to the power of 0 equals 1. A to the power of 0 equals 1. 100 to the power of 0 is equal to 1. 2 to the power of 0 equals 1. So that's for the zero index law. And looking about to the next, we have the negative indices. This law states that if you have a problem such as this, a to the power of negative n, a to the power of minus n, negative n, what you have to do is change this to a fraction by introducing 1. So because of this negative sign, we have 1 over a to the power of n. So this negative sign changes to 1 over, and then we have a to the power of n. So this negative sign changes to 1 over, and then we have a to the power of n. This is for the negative indices. And let's say, for example, we have 2 to the power of minus 3. So this will give us 1 over 2 to the power of 3. And if we have this is 1 over 2 is the power of 3 is 8, 1 over 8. Common mistakes we need to avoid. There are common mistakes. If you notice, because I said if they have the same base, under the multiplication rule, you should add the parts. Most of you will go ahead and do this. 2 to the power of 2 plus 2 to the power of 3. And then you pick 1 and you add the parts. This is totally wrong. This is totally wrong. You don't do this. This law only applies if there is a minus sign. If there is a multiplication sign, if there is a multiplication sign, that is where you apply that rule or that law. So you don't apply that rule for this. If you have to solve this is 2 to the power of 6, 4, 2 to the power of 3, 8, and here you have 12 times 3. So this will give us 1 over 2 to the power of 3. And if we have this is 1 over 2 to the power of 3 is 8, 1 over 8. So it is that simple. Common mistakes we need to avoid. There are common mistakes. If you notice, because I said if they have the same base, under the multiplication rule, you should add the parts. Most of you will go ahead and do this. 2 to the power of 2 plus 2 to the power of 3. And then you pick 1 and you add the parts. This is totally wrong. This is totally wrong. You don't do this. This law only applies if there is a minus sign. If there is a multiplication sign, sorry. If there is a multiplication sign, that is where you apply that rule or that law. So you don't apply that rule for this. If you have to solve this is 2 to the power of 2 is 4, 2 to the power of 3, 8, and here you have 12. You can see the difference. So you don't apply this rule where they have an addition sign at the middle. Another mistake to avoid when solving is this. Now, another mistake to avoid when solving this is this. A plus B all raised to the power of 2. It is not equal to A to the power of 2 plus B raised to the power of 2. This is absolutely wrong. This is absolutely wrong. Not because I said when you have A, B to the power of n, you give them individual powers. That doesn't apply here. If you notice, this is joined by a multiplication sign. You can see we have the multiplication sign here. So 2 times 5 to the power of 3. That's where you can apply this. But because there is an addition sign here, you don't work with this principle. So let's look at some questions. Question 1 says 4 to the power of 2 multiply 4 to the power of 3. And then question 2, it says 2 raised to the power of 3 all raised to the power of 2. And for question 3, 5 raised to the power of -1. So solution, 7 for question 1 says 4 to the power of 2 multiply 4 to the power of 3. So like I said, we pick out one of the ways. So we have 4 here. And then because there is a multiplication sign, we add the powers. So 2 plus 3. And this will give us 4 to the power of 5. So this is how to solve question 1. Now moving about to question 2. So moving about to question 2. Question 2 is 2 to the power of 3 all raised to the power of 2. Now, to solve this, we pick out the base, which is 2, and we multiply the powers. Sorry, times 4. And we have here 4 times 4, 16. 16 times 4, 64. 64 times 4. So 64 times 4, 256, and then 256 times 4, 1024. So you can proceed to simplify further. Depending on the question. If the question says leave it in index form, then you stop here. So same thing applies to this. So looking at another question, it says if 5 to the power of x equals 125, find x. They are only asking what power will you multiply 5 into that will give you 125. This is very easy to solve. So first of all, you have to express 125 in terms of 5. So the idea is this. This is the base. What index will you multiply this base into that will give you 125? So here is what we do. We have 5x equals 125. So first of all, if you do 5 times 5 will give you just 25. So invariably this is wrong. Now we do 5 times 5 times 5. So 5 times 5 is 25. 25 times 5 is 125. So 125. And you can see here we are having 125. So how many times did you multiply 5 to get it 125? We multiply 5 3 times 1 to 3. To the power of 5 equals 3. So 5 to the power of 3 will give us 125. If you notice, initially what we had here was x, so 5 to the power of x, this x is an unknown number, equals 125. And now we found out that 5 to the power of 3, 5 multiplies 3 times to give us 125. So 5 to the power of 3 equals 125. These questions, first we are given number 1, find 4 to the power of 0. That says find 5 to the power of 6 divided by 5 to the power of 2. Number 3 says simplify 27 raised to the power of 1 over 3. Number 4, simplify 16 to the power of 3 over 4. And number 5, evaluate 3 raised to the power of 4 multiply 3 raised to the power of 2 divided by 3 raised to the power of 3. And number 6, simplify 1 over 3 to the power of minus 2. Number 7, simplify 9 to the power of 2 all raised to the power of 1 over 2. And then the last one on the list, simplify 64 to the power of 1 over 2 divided by 8 to the power of 2 over 3. So let's start with number 1. Number 1 says, I said anything raised to the power of 0 equals 1. So automatically our answer here is 1. So this is our answer. Anything to the power of 0 equals 1. For number 2, 5 to the power of 6 over 5 to the power of 2. 5 times 5 times 5 times 5, 1, 2, 3, 4 times 5 times 5 divided.
I want pause.
So divided by 5 times 5, which is 5 raised to the power of 2. So I'm going to show you two methods on how to solve it. This is the first method. So I can easily cancel out this and cancel out 25, cancel this, cancel this. So we are left with just 1, 2, 3, 4, 5 to the power of 4. We are left with 5 to the power of 4. So we are left with this. Now, the another way to solve this is 5 to the power of 6 divided by 5 to the power of 2, which can be written as 5 to the power of 6 divided by 5 to the power of 2. The base are the same, the big one. So this is 5. You see, if you are dividing, you subtract the powers. 6 minus 2. So 6 minus 2 is what is 4. 5 to the power of 4. So our answer is 5 raised to the power of 4. So whichever one we want to use, either this 5 raised to the power of 4. So whichever one we want to use, either this method or this method, is the same thing. It will give you the same answer. So our final answer is 625. 625. So if you are told to leave the answer in units form, you leave it this way. Whereas you can also leave it this way, depending on the option given. Now let's work for number 3. Number 3 is simplify 27 to the power of 1 over 3. Now, if you are given something like this, I forgot to mention this under the note of indices. This numeric denominator, the denominator serves as a root. So, if it's 3 that is given here, it serves as a cube root. If it's 2 that is given here, it serves as a square root. Meaning that if I'm to rewrite this, I will rewrite this as cube root of 27. Cube root of 27. Assuming this was 27 to the power of 1 over 2, this would be a square root of 27. But the fact that the denominator is 3, it is cube root. If the denominator was 4, it would be 4th root. If it was 5, it would be 5th root, just like that. So, cube root of 27 is equals to 3. So the cube root of 27 is 3. To confirm this, 3 raised to the power of 3 will give you 27, because 3 times 3 times 3 will give you 27. 2 times 3 is 9, 9 times 3 is 27. So the cube root of 27. So next we have number 4. For number 4, it says simplify 16 to the power of 3 over 4. 16 to the power of 3 over 4. Now, how do we solve this? First of all, we express 16 to have the power of 4. So, what will you multiply 4 times to give you 16? That is what I'm trying to say. Express 16 to have the power of 4. So, what will I multiply 4 times to this? First of all, we express 16 to have the power of 4. So, what will you multiply 4 times to give you 16? That is what I'm trying to say. Express 16 to have the power of 4. So, what will I multiply 4 times to give me 16? And that's 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So, I'm having 2 to the power of 4 multiply 3 over 4. I don't know if you understand what I did here. I said, first of all, express 16 to have the power of 4. So, what will I multiply 4 times to give me 16? That is 2. So, we are now writing 16 as 2 raised to the power of 4. And 2 raised to the power of 4, remember our power here is 3 over 4. So 2 raised to the power of 4 multiply 3 over 4. This power here, 4 here, we cancel 4 here. We are left with just 3. So this will give us 2 to the power of 3. 2 to the power of 3. And 2 to the power of 3. Because the instruction says simplify. It says simplify. We will go ahead and solve this. 2 to the power of 3 is 8. 2 times 2 times 2. 2 times 2 times 2 equals 8. So this is our final answer. Because the question says simplify. Now let's solve for number 5. For number 5, it says evaluate 3 to the power of 4 times 2 raised to the power of 2 divided by 3 to the power of 3. Now, how do we solve this? If you look this way, you'll see the multiplication law of indices. So we have to tackle this first before solving. So tackling this first, the base are the same, 3 and 3 here. So we pick out 1. And then the powers, we add the powers. 4 plus 2. 4 plus 2 is 6. 4 plus 2 will give us 6. And then we now bring down our denominator. So our denominator here is 3. So we have 3 to the power of 6 divided by 3 to the power of 3. Next thing we have this. We apply the division law, meaning this base and this base are the same. So we pick 1 is 3, and then we subtract the powers. 6 minus 3. 6 minus 3 is 3, so we have 3 to the power of 3. 3 raised to the power of 3 is equals 27. So we have 27 as our final answer. Now, solving for number 6. Number 6 is 1 over 3 to the power of minus 2. Now, how do we solve this? So, this is under the negative index law. First of all, because of this negative sign, we introduce the fraction 1 over. So we have 1 over. And what do we have here already? Here we have 1 over 3 already. So we have 1 over 3 to the power of 2. Now, if I'm to rewrite this now, leaving out this square, leaving out this 2, this will give me 1 divided by 1 all over 3. So this is how to rewrite this. 1 divided by 1 over 3. If I'm having 1 divided by 1 over 3, I want to change this division sign to multiplication sign. I'll be having 1 times 3 all over 1. So 1 times 3 all over 1 is same thing as 3. 1 times 3 divided by 1. So this is same thing as 3 all over 1. And 3 all over 1 is still 3. So 3 all over 1, this is 3. Now remember, this had a square, so you have 3 square. We are having 3 to the power of 2, and 3 raised to the power of 2 is equals 9. And this is the final answer. Recall, first of all, because of this minus sign, you introduce 1 all over, and then you can see 1 over 3 already. So 1 over 3 to the power of 2, this 2 here. We now with 2, or you can solve ahead with 2. 1 divided by 1 over 3. So we write this as 1 divided as 1 divided by 1 over 3, and then we change the division sign to multiplication. So our 3 will go up, and then 1 will come down. So this is 1 times 3 over 1 equals 1 times 3 over 1 is same thing as 3 over 1. 1 times 3 is 3 over 1. So 3 over 1 is same as 3. 3 to the power of 2, this 2 here, 3 to the power of 2 was 9. And this is our final answer. Number 7. Number 7 says 9 to the power of 2 to the power of 1 all over 2. 9 to the power of 2 to the power of 1 all over 2. So we multiply the powers. Remember, we pick out the 9, and then we multiply the powers. 2 times 1 all over 2. 2 times 1 over 2. 2 here will cancel 2 here, and then we are left with 9 to the power of 1. And 9 to the power of 1 is same thing as 9. So this is our final answer. And lastly, we have number 8. Number 8 says 64 to the power of 1 over 2 divided by 8 to the power of 2 over 3. So how do we solve this? Recall, when we solved number 4, I said express 16 to have the power of 4. And then we say 16 can be written as 2 to the power of 4. Now, same thing applies here. Express 64 to have the power of 2. So if I'm to write 64 as a power or as an index, I will have 8 to the power of 2, because 8 times 8 is 64. So this is 8 to the power of 2. multiply 1 over 2, because we are not using this power. So multiply 1 over 2, all divided by, same thing applies here. Express 8 to the power of 3, to have the power of 3. So if I'm writing 8, I'm writing 8 as 2 to the power of 3, because 8 is same thing as 2 to the power of 2. 2 raised to the power of 3. 2 times 2 times 2 will give us 8. We have 2 to the power of 3 times 2 over 3, which is this power, is 2. Note all the steps we do. So number 1, we say 4 to the power of 0 is 1. Because anything to the power of 0 is 1. Here, I gave you 2 steps. You can either use 5 times 5 times 5 times 5 times 5, and then you cancel out, and you arrive at 5 to the power of 4. Or you pick out one of the base 5 and then you subtract the powers. So this will give us 5 to the power of 4. And 5 to the power of 4 is 625. For this one, number 3, I say 27 to the power of 1 over 3. Whatever you have as the denominator here, you serve as the root. You serve as the root. So if you have 2 here, it will be square root. If you have 3 here, it will be cube root. But the fact that you have 3 here, it's cube root of 27. And cube root of 27 is 3. Coming back to number 4. For number 4, 16 to the power of 3 over 4. I say express 16 to add the power of 4. So if you are writing 16 to add the power of 4, we have 2 to the power of 4. Put 2 to the power of 4 times 3 over 4, which is the power that was here. We cancel out 4 and 4, and we have 2 to the power of 3, which is 8. For number 5, I say 3 to the power of 4 times 2 to the power of 2 divided by 3 to the power of 3. Solving for this, we pick out one of the base, which is 3, and then we add the power because it's multiplication. So multiplying, we add the powers because the base are the same. So 4 plus 2 is 6, and then we bring this here, 3 is the power of 3. Because we are dividing, we subtract, and we give us the basis, and then 6 minus 3 give us 3 to the power of 3, and then we have 27. For number 6, I take 1 over 3 to the power of minus 2. Because of the negative sign, it will use 1 over, because of the negative sign. And 1 over what? 1 over 3. So 1 over 3 to the power of 2. Writing this, we have 1 divided by 1 over 3. And changing the division sign to multiplication sign, we see 1 times 3 over 1, and 1 times 3 over 1 equals 3 over 1, which 3 over 1 is equal as 3, and then we introduce our power, which is 2. 3 to the power of 2 is 9. Don't forget this power, please. And for number 7, we state 9 to the power of 2 all to the power of 1 over 2. We multiply the powers, so 9 to the power of 2 times 1 over 2. We cancel out 2 and 2, and we are left with 9 to the power of 1, and it gave us 9. And lastly, 64 to the power of 1 over 2 divided by 8 to the power of 2 over 3. So rewriting this in terms of the power 2, 8 here. Writing this in terms of the power 3, 2 to the power of 3 will give us 8. So 2 raised to the power of 3 times 2 over 3, which is the power here. And 3 will cancel out 3, and we are left with 2 raised to the power of 2. So 8 to the power of 1 divided by 2 raised to the power of 2 equals 8 divided by 4, because 2 to the power of 2 is 4. And 4 here 1, 4 here is 2. We are left with 2. So this will be all on indices. Watch out for our next video, and ensure you subscribe to this channel for more tutorials on science topics, science subjects, both as to a full package tutorial. And if you want to join our JAMB classes, ensure you test the number on the screen to join our JAMB classes for those preparing for JAMB. See you in the next video.